Let's solve our next problem from LeetCode 150 list. And the next one is search in a 2D matrix. So let's go. So from the patterns, we already know this is going to be a binary search problem. But let's see what is the question. So we have given a matrix and each row is sorted in order. So each row, this one, is sorted and first integer of each row is greater than the last integer of previous row. So this is greater than this. That means um, it is also sorted in column wise, not actually column wise, but you will what how can I say it? So yeah, so it is sorted and these are all sorted basically, and our job is to find the number if it is present or not. So I immediately after reading this, I can think of a lot of options to do this. The main one is binary search, but let's say we can do the brute force. We can just scan from left to right till the end and just go. That's uh, gonna be of m into n time complexity. Another thing I can see is binary search, but there are a couple of ways I can do the binary search. So we can create uh, from this 2D matrix, we can create a single array, like a single matrix, by joining these all the rows and then do the binary search on it. Another way is we can do the binary search on complete matrix, like starting from here and then moving the middle point from here to here or here. The easiest I think is to just find the row that will have this number, and once we find the row we can find the number if it is present or not. So I'm gonna go with that approach. It's gonna be log of m into n. So let's see how I'm gonna do this. Let's do this m and n. Let's so length of matrix and length of matrix of 0. So we got the lengths. Now first thing is find the row that might have the number. So I'm gonna declare um, final row is equal to -1, and we'll try to fit it somewhere, and then we're gonna have and bottom top and bottom, which will be 0. And so if this is number of rows are n, so we're gonna be bottom gonna be n minus 1. Now we're gonna run binary search on this particular area like this. Okay, so how are we gonna do this? So it's a same uh, binary solution pattern. So it's gonna be top is less than equal to bottom. While this is true, we're gonna calculate mid. So mid will be top plus bottom minus top divided by 2. So this is another way to avoid overflow. In Python it works without this, but for most languages you need to do this. Once we have mid, so what does that mean is we found a row that is mid. So what we have to do is this target in between this start of this row and end of this row. So if uh, if the matrix of mid of 0, so first element should be less than or equal to our target, and target should be less than or equal to our end of this row, so which is m minus 1, right? So m is the number of columns, so minus 1, that's the last element. So if our target falls between any of the of this start of this row and end of this row, only then we found our row. So that's when we break, right? But before breaking and stopping this loop, we want to update the final row. So we do this is equal to mid. Now what can happen is, else if you could, the target could be less than the start, or target could be more greater than the last of this row. So in that cases we have to move our mid. So let's do that. So if our target is now less than the start of this row, then it is simple that we have to move our bottom to the row mid minus 1. So we do bot is equal to mid minus 1. Else is the last case where it's not, then it will be greater than this, because it's not in between, it's not less than, that means it is greater than. So in that case we have to move the top. So for example here, if it is 31, then it is greater than 20 and it will come here. So mid plus 1. So after this we have found our final row. So let's say if there was a number we are searching for minus 10. So in our case it will come till here and it will still not find it, and after this case the top and bottom will not be equal, they will interchange. I mean top will be greater than bottom. So we will never set the final row. So if that's the case, then we have to return already false. Like for example, minus 10 is not present, we already know, because it is not falling in any of the rows. So let's do that. So if final row is equal to minus 1, then just return false from here. That's it. Now once we are not returning, that means we found a number that is in between this row, then we'll do the normal binary search. How we'll do that? So normal binary search on the row. So we repeat the same code again. So we're gonna do left and right for row. We're gonna start from 0 and the row right will be m minus 1, and again the same loop. While L is less than equal to R, we want to find the mid, and mid will be left plus R minus L divided by 2. And if now this mid is different, this is between the row, so we will do a matrix of we already have a final row, so we're gonna not change this will be constant, and our mid. So if we found this target, right, then we return true from here, and that's it. Otherwise, else if we'll check if target is less than mid. So if we are trying to find, let's say this is mid and we are trying to find 12, then it will be falling in this side, not this side. So we'll change the right part. So right will be mid minus 1. Otherwise left will be mid plus 1. I hope this is correct. So once we go all the way, we'll find if it is present. For example, if we are searching for 3, we'll find it. If we are searching for 13, we'll not find it. In this case, we'll come here, we'll not find it. So we'll return false from here. I guess it's a big code, but I'm gonna try and run it if there are no more bugs, I think. Okay, that's accepted. So what I usually do is before submitting, I just create few more cases. So for example, edge case would be to find the first element. So we're gonna do this. Another could be to find the last case, and another could be a number that's lower than our expectation. Sorry, starting point to end point. So let's see if this works. It is still working, so I think this is correct solution. I'm gonna submit. Cool. So it's working and it's pretty efficient. So thank you. This has been Big Head. See you in the next one. Have a great day.